Okay, let's solve mini quiz number 7.3. Okay, we're talking about function inverses, and we have let j of x equal 3x minus 6, right? So j of x is this 3x minus 6 function. And the first question just asks me to find the inverse and show that my final answer is this thing. Okay? To find the inverse of a function, all I have to do is solve for the input variable as the output, right? So if j of x equals 3x minus 6, well, I can call this y if I want, just to make it a little easier to move around, right? And now I can just solve for x instead of y. So let's add 6 to both sides. Y plus 6 equals 3x. And now if I divide both sides by 3, there we go. I get x equals y plus 6 over 3. And now I've found my input as a function of my output. Okay, so now the input and output have switched. The only thing I have left to do is just rename them y and x. Okay, this is just my renaming step to show that this thing is now my input. So my output is now my input in the inverse. There we go. So F inverse of X, that's this thing here, is just X 6 all over 3. Great. All right, let's find J of 4. Well, J is just 3x minus 6. So J of 4 is just that with the 4 plugged in where the x should go, right? 3 times 4 minus 6, that's just 12 minus 6. Ah, that's just 6, right? Nice. How about J inverse of 6? Well, I could put 6 into this expression here, which many people did. So let's try that. So J inverse of 6 is simply 6 plus 6 over 3. And wait a minute, that's just 12 over 3. Well, that's just 4. And hey, wait, that makes sense, right? My function j turned 4 into 6. So it makes sense, it stands to reason that my inverse should turn 6 back into 4, which is exactly what we found. Okay. How about this? J of J inverse of 300. J of J inverse of 300. Well, a lot of people did this the long way by first finding the inside expression and then subjecting that to J. We could try that, right? J inverse of 300 is just 300 plus 6 over 3. Well, that's just 306 divided by 3. Well, that's just 102, right? That's J inverse of 300. And then I would have to hit that with J. So J of 102 in turn is going to be 3 times 102 minus 6. Wait a minute, that's just 306 minus 6. Well, that's just 300. Oh, wait, hang on. I just got 300 back out. I didn't need to do any of that stuff because J inverse and J just do the opposite of each other, right? So if J inverse turns 300 into something, then J is going to just reverse the process and turn it back into 300, right? So all of this working out here, it's all well and good. No big deal that I did that extra work, but logically, I should just get 300. I didn't really need to do that. As a bonus, right? As a bonus, can we confirm why this expression and this expression are inverses? Okay. In other words, let's find an expression for j of j inverse of x. So just to remind ourselves, j of x is 3x minus 6. J inverse of x is just x plus 6 all over 3, right? So to find this expression, all I need to do is take this expression and plug it in to that x, just like we did in 7.2. All right, so let's just do it. So j of j inverse x is simply 3 times, well, this whole thing, x plus 6 over 3 minus 6. And if I put parentheses around the top here, I can see that 3 times something divided by 3 is simply x plus 6 minus 6 again. So this first term here becomes x plus 6. And x plus 6 minus 6 is simply x, right? J of j inverse of x is simply x. And this shows us why these two expressions are inverses. Why these two functions are inverses. Because j inverse did something to x here, but then regular j just changed it back. And all of this ended up doing nothing to x. Okay? And that's what inverse means. Okay? So all this is to say that inverses switch outputs and inputs. The inputs become the outputs, and the outputs become the inputs.